Today we're going to talk about the altitude hypotenuse theorem. It states that if the altitude is drawn to the hypotenuse of a right triangle, there's the altitude, then the two triangles formed are similar to the original triangle. Okay, the original triangle is the big one, and it creates two smaller triangles, here and here. Now remember that anytime there's an altitude, it actually has a right triangle. It forms a right triangle to the base. So all three of those are right triangles, and they are similar to each other. Those three that are formed are similar. So we have triangle, the original triangle ABC. It's right triangle there. We form triangle DBC, and we form triangle A, D, and B. Okay, those three are all similar. So if we were going to write a similarity statement, we would write this as triangle ABC, which is that one, is similar to triangle BDC, which is that one, which is similar to triangle ADB. Remember, how you write these similarity statements matters, the order that the letters are in, because ABC has to correlate with BDC, so each angle has to correlate with the other angle. Now here's another diagram that kind of shows it in a different way. Here's the original triangle they started with. They drew an altitude to create three similar triangles. These are your three similar triangles. We're going to go ahead and write a similarity statement. And I'm going to start with the small one down here and just work my way up. So triangle TUS is similar to triangle RUT, which is similar to triangle RTS. Okay. Now the big thing you need to remember with similar triangles or any similar polygon is that all of the interior angles are congruent, meaning they are the same or equal. And all of the sides, while they are not congruent, they are proportional. So they will have the same proportion on each of the sides. Here's an example of a problem you will come across in geometry. This gives us a diagram of a swimming pool. It asks what the maximum depth of the pool is. So at the bottom part, you can see they have a big triangle that they drew an altitude. Okay, and right there where the right angle is where the maximum depth of the pool will be. So really we need to find the height of that altitude to be able to find the maximum depth. Now when they drew that altitude in there, that gives us again three similar triangles. Okay, and I'm going to look at triangle, first the big one, which is triangle RTS. And I know it's similar to the smaller one, this one right here, which I'm going to call triangle RMT. Okay, now we know those sides are proportional. I'd like to use my BS rule, which means as you set up proportions, you go big to small is equal to big to small. So you look at the same sides. So the first thing I'm going to do is look at the hypotenuse of the larger triangle, which is 165. And I'm going to put it over top of the hypotenuse of the smaller triangle, which is 152. Now, since I need the shorter side, that's the height of the smaller triangle, which I'm going to put down here. I'm going to find the shorter side of the larger triangle, which is 64. Now the next step is to cross multiply. So we'll get 165h, or the height, equals 152 multiplied by 64. Okay, 165h equals 152 times 64 equals 9,728. Then to solve for h, I'll divide both sides by 165, and I'll find that height to equal let's see, 9,728 divided by 65 equals 165 equals 58. Well, 58.96, which I'm going to round to 59 inches. Okay, so that's the height of the altitude. To find the maximum depth, I'm going to have to take that height and add it to the 48 inches above that. So 58 or 59 plus 48 equals 59 plus 48 equals 107. So the max height is 107 inches. And that would be my answer. Here's another example. In this case, it's just going to ask you to find x. So I can see that the larger, in number 1, I can see that the larger triangle has all 3 of its values. So I'm definitely going to want to use that as I set up my proportions. Now again, any similar triangle, that means they have congruent interior angles, and then all their sides have the same proportion. That's why we can set up these proportions. So I'm going to use my BS rule again. Big to small, big to small. Then on the larger one, I can definitely see, actually I'm going to identify, I'm going to go ahead and use the large triangle. I'm going to compare it to this medium-sized triangle. Okay, so in the larger triangle, I can see that the hypotenuse is 5. And on my smaller triangle, I can see the hypotenuse is 4. Okay, on the larger triangle, the smaller side is 3. And on my smaller triangle, the smaller side is x, which is what we're trying to find. So when I set this up, now all I have to do is solve for x by cross multiplying. And I get 5x equals 4 times 3, which is 12. Now, to solve for x, I just divide both sides by 5. And I get x equals 12 over 5, or x equals 2.4. That would be your answer. Now I will let you try 2 on your own, and I'm also going to add some other links to some videos that explain how do we use similar triangles also. Thanks.